Subjective 101. So 100 was the last of the imaginary. So 101 is where we start something completely new. All right, the first thing you need to know is what a quadratic expression is. Now, who can tell me? Because there's like 20 some odd of you in here.
But you're the smartest.
The biggest type of variable piece is a squared piece.
The biggest type of variable piece is
It does
a
say quad.
squared piece. All right, that's right. If you look at it, the biggest type of piece is a squared piece. So here's what that means. You know what an expression is. What's an algebraic expression? Some with algebra, but it doesn't have a what in it?
An equal sign.
It does not have an equal sign. If
3x+6.
you're looking at a bunch of pieces of junk that look like algebra, but there is no plus or no equal sign, it's an expression. So when I say a quadratic expression, I'm talking about one of those expression things, but the biggest type of piece that you're going to see is an x squared piece. So you might have like 3x squared minus 7x plus 2. How many pieces are there? 3. And when I say the biggest type of piece, like the biggest x piece you got is x squared. If I said x to the third, that's not quadratic. It's got to have an x squared in it, and that's the biggest type of piece. Yeah, it also has an x piece, and it has a number piece. So the most type of pieces you can have are 3. You can have an x squared piece, an x piece, and a number. You don't have to have them all. You can have just the x squared piece and the number piece. So say that you said 6 plus 5x squared. It's quadratic. How do I know?
Because of the x squared.
Because of the x squared piece. Here's the question. If I say, is it quadratic, you just have to say, is there an x squared piece, yes or no?
Yes.
Yes. Are there any other bigger type of x pieces, like x4s or x5s?
Yeah. No.
No, you said there's
Yeah.
x2.
Yeah, there's no x4s or x5s. So then I could also have 6x minus x squared. 6x minus x squared. Is that expression quadratic?
Yes.
How do you know?
It's got an x squared.
It has an x squared. Does it have x3s or x4s or x5s? No. So come over here and let's talk about what's not quadratic right here. But not. So what would not be quadratic?
3x plus
3x plus
3.
3x to the third. How do I know that's not quadratic? Yeah, it's got an x3 piece. Also, this one right here, if I just said 7x plus 2, that ain't quadratic either. Why is that not quadratic? There's no squared piece. The biggest key is you got to have the squared piece, and then you can't have pieces bigger. So if you have the squared piece, so that say you got 2x squared, but then you can't go 5x to the 4th. So here's some knots. You got some good ones and then some knots. 3x plus 3x to the cube. No. Or 7x plus 2. It's missing the x squared. Or 2x squared plus 5x to the 4. It was good, but the x to the 4 ruined it. So it's not quadratic. So when we talk over the next few months about what something quadratic is, you need to understand I'm talking about something in algebra where you've got an x squared piece. And you don't have any x3s, x4s, or x5s. But you got to have the x squared piece. Now what we're going to do today is called factoring the GCF from a quadratic expression. So you're not dealing with equations here. I'm going to give you some algebra junk, and then I'm going to ask you to factor the GCF out of it. And you might not know what that means yet. But hopefully after looking at some examples, you'll kind of get the hang of it. This is going to be the first type of factoring you're going to learn. And we've actually talked a little bit about it. And some of you who have worked ahead, we've kind of seen more of it than others. But the first type of factoring, first of a few, is going to be factoring out the GCF, the greatest common factor of a binomial or trinomial. A binomial is how many pieces? 2. So I might have 2x plus 4x squared. Something like that. That's binomial. We're going to factor something out of it. A trinomial is how many pieces? 3. So I got 3x plus 9x squared plus 3, or minus 3. Now what factoring the GCF out means is it's the opposite of distributing. You've learned how to distribute. Some of you guys are like, you guys have been here for Algebra 1, Geometry, and Algebra 2. You distribute every year. Well, factoring is the opposite of distributing. So instead of multiplying something in, I'm going to divide or take something out. So our very first example of how to undistribute is going to be 3x plus 9. Now is this quadratic?
No.
No, but I'm trying to make it basic. And how did Josie know it's not quadratic?
Squared.
No x squared. But it is a binomial, right? Okay. So what I'm going to do is I'm going to look for the GCF, and I wrote it right here. The GCF is 3. But if I look at these two pieces, this one and this one, there is one integer that I could divide both of them by evenly, and that is 3. I can divide 3 by 3, and I can divide 9 by 3. So what I'm going to do is I'm going to take that 3 and put it outside of a parenthesis. Just like when you distribute, you take a 3 and put it into a parenthesis. I'm going to take a 3, undistribute it. Now, if I divided the 3 off of this, it just makes it x. And then if I took that 9 and I divided the 3 off it, it's going to become what? 3. So this is your first factoring. You take the 3 off, and then you make this an x and this a 3. And if you did it right, you should be able to mentally look at it and redistribute and get back to where you started. So if I go 3 and x, that makes your 3x. And if I go 3 times 3, there's your 9. So if done right, you're putting a number outside of a parenthesis, and then if you redistributed it, you get back to what you started. What we're trying to do is undistribute. Factoring the GCF is undistributing some sort of number. All right, let's look at example 2. Example 2 here. Now this is a binomial, and is it quadratic?
Yes.
Yeah. How do we know it's quadratic?
X squared.
They got the x squared piece on there. So it's definitely quadratic because there's x squared piece. There are no x3s, x4s, x5s, and so on. Here's what I want to do. I can take off, like, can I divide both of these by 4? I can divide that by 4. Can I divide that by 4?
Yeah.
But I can do one better. Both of these pieces have an x on them. This is an x squared. This is an x. If both pieces have an x, not only can I undistribute a 4, I can undistribute an x. So I'm going to put my 4, but since they both have an x, like even though this is x squared, that's just like a better x. I'm going to put 4x outside the parenthesis. Now when I take the 4 off of this one, it's gone. There's no 4, it's just a 1. If I take one of those two x's off, it leaves me with 1x. I had x squared and I took 1 off. X. Now with the 12, you divide 12 by 4 and you get what? 3. But if I take 1x off of it, I took that x and took it off. So I end up getting x plus 3. If you redistribute this, does this make 4x squared?
Yes.
Which is that. Does this make 12x? Yeah. So in this case, since both pieces had an x squared and an x, we took the 4 off, but we took 1x with it. So we took a little bit more. We put the 4x outside. So your GCF is actually 4x. Undistributed 4x. All right, let's look at, these are binomials. Let's look at a trinomial. This is a quadratic trinomial. What makes it quadratic? X squared, and there's no x, 3s, 4s, 5s. What makes it a trinomial? There's 3 pieces. So it's a quadratic trinomial. What I'm going to do is I want to take the GCF off of this. Now, last time I took an x off because every piece had an x or an x squared or something. This has an x squared, this has an x, but this one has no x. So I cannot take an x off of all 3 pieces. So forget taking any letters. But what I can do is see what I can divide these by. Now, I can divide this by 9. I can divide this by 9. Can I divide this by 9? So that's what I want to do. If you can take the 9s off. Otherwise, if that didn't work, we would try like 3 or something else. Let's undistribute a 9. So what am I going to do? What am I going to write? 9 and then parenthesis. And then let's think. If I took the 9 off this, what's left?
X squared.
X squared. All right, let's go to the next piece. If I took the 9 off that, what's left?
Nothing but X.
Just x. And then I take a 45, and then when I say I take a 9 off, I divide a 9 off. So 45 divided by 9 gives you 5. And that's it. Now, if you're not sure, and if you want to make sure you got the right answer, just do a real quick check of redistributing. Does this make 9x squared? Does this make 9x? Does this make 45?
Yes.
Then it's done right. If you redistributed this 9, you should get back to the trinomial you started with. All right, we have a weird binomial down here. And they use p's instead of x's because they're going to mix up the letters a little bit. All right, so factor this. Now, is it a binomial or trinomial?
Binomial.
It's a binomial because it's 2 pieces. Do both those pieces have a letter on them?
Yes.
So I can take it off. So if I got a p squared and a p, I'm going to factor off a p from both of them. Take a look at this one note though. Notice how our leading, this is how they call this our leading coefficient or our leading piece, it's negative. If your leading piece is negative, you're probably going to factor it off as a negative. Both of these things are divisible by 5. But since the leading one is negative, I'm going to actually take off a negative. I'm going to pull a -5 and put it outside the parenthesis. But I had to put the p with it because both of those pieces had a p. So let's think. If I took -10 and divided it by -5, what do I get? Positive 2. But then, yeah, I only took one of those p's off, so there's still one p left. Now I take -15. If I took a -5 out of it, which means I divide a -5 off of it, it becomes what?
-3.
-3.
-3, yeah. And then I took one p off of it, so is there any letters left? No. So then this is what we should have. And what do we need to do to check to make sure we did it right? Distribute. It's real quick. Does this make -10p squared? Does this make positive 15p? Then we did it right. All right, so on the bottom, what I have is I want 2 that I want you to try. Notice that the second one starts with a negative, so you're going to take a negative off. So try this binomial and try this trinomial. I'm going to go ahead and write them up here, but I want to give you a minute. See what you can come up with on your own. All right, a lot of you do have this done already. You take a 4 off of each of these. When I'm looking at this, and I'm trying to figure out what number I'm going to take off, I might look at this 16, that's the lower of these two, and I'm going to ask, can I divide both of these by 16? The answer is no. So then I have to go, what's less than 16? Well, maybe half of 16, maybe 8. I can divide this by 8, but I can't divide this by 8. So it's got to be smaller. So then I go, okay, if it's not 8, maybe it's 4. I can divide this by 4. I can divide that by 4 as well. So I found the number. But then also, since that's a c squared and a c, I can pull a c off of both of them. So 4c is your GCF. 28 divided by 4 is what? 7. And you had c squared, but you pulled one c off of it, so it became c. And now on 16, you divide that by 4, and you get 4, but then you take the c off of it. So it's just plus 4. And it redistributes. There's your 28c squared, and there's your 16c. Now on number 2 over here, I look at the smallest number, which was 7, and this works fine. Can I divide all 3 things by 7? Yes, yes, yes. But because the leading coefficient's negative, I'm actually going to take off -7. Now, why did I not take a q as well?
Because not all of them have Q.
Not all of them have q. The first 2 had q's. I could take q off that and that, but if you're going to undistribute a q, they better all have a q to redistribute. So I could. So -14 divided by -7 made positive what?
2q.
That's 2q squared. 2q squared. I didn't take any of the q squareds off. Then -7 divided by -7 made positive 1. So it's just plus 1q. -21 divided by -7 made 3. If done right, you should be able to redistribute -14q squared, -7q, and -21. All right, what we talked about today, something that you did not know. The word quadratic, what does it mean to you? X squared and nothing higher. X squared and nothing higher. So you know you're looking at a quadratic when you got x squared and nothing higher. All right, let's go ahead and get started.